All right, friends, let's see what we've got. L is a line tangent to the graph of x to the n at the point 1, 1, where n is greater than 1. Well, so n is some number greater than 1. If L is tangent to n, that means if I take the derivative, nx to the n minus 1, that's just power rule. When x is 1, that's the slope of L. So slope of L, that's an and, slope of L is n. Because if I make x 1, then I can find the slope of L. Wait, I see an S and a T here, so I'm guessing I'm going to have to find some areas. And that's going to be an interesting move, but we'll figure out how to do that. The T area looks like a triangle, so that would probably be an easier move. And then the S area, we'd almost have to do it area this way if we're going to find the area. And then if we start rotating or whatever, that could be interesting. We could certainly find the perimeter. So we'd find whatever this distance is, which would be finding the x-intercept of this line, find this length by the Pythagorean theorem, and then find the curve length using our ability to use calculus. But that's about all I can gather from that stem of the question. Now, what do we have? We have the stem of the question. Find the integral 0 to 1 x to the n in terms of n. All right, so my question is, whose derivative is that? Well, as I did on the front page, the derivative of this is nx to the n minus 1. So if I have x to the n as the underderivative, then it'd be n plus 1, but I have to divide by n plus 1. Because if I take the derivative, the n plus 1 comes down, cancels out, and then you have x to the n. So it's going to be x to the n plus 1 over n plus 1 from 0 to 1. So this is using the fundamental theorem of calculus, the evaluation portion of life. Now let's go ahead and plug in. And so we're plugging in 1 for x. So 1 to the n plus 1 over n plus 1. And then we're plugging in 0 for x. 0 to the n plus 1 over n plus 1. And that's going to be 0, that stuff goes away. 1 to the n plus 1 is just 1, because that's 1 multiplied by itself n plus 1 times, however many times that is. And then divided by n plus 1, so I'm going to get 1 over n plus 1. And that's all I have to do for that question. Let's see, what's part B? Still the same stem. T is the triangular region bounded by L, the x-axis, and the line x equals 1. Show that the area of T is 1 over 2n. Well, we found from the previous page that the integral is 0 to 1 of x to the n dx is 1 over n plus 1. I don't know if that's helpful, but I remembered that, so I wrote it down. Bounded by the line L, x-axis, and... okay. So this distance is 1, I can tell you that. So I need this. I need 1 times that distance divided by 2 to be 1 over 2n. So I need question mark to just be 1 over n. And let's figure out why that would be 1 over n. We already established that y prime was nx to the n minus 1. I talked about that on the first page. And that tells us that the slope of line L, that's still an and, silly, slope of L is n. So that means the equation, here we go, equation of L is y equals the y value plus the slope and then x minus 1. So when y is 0, when y equals 0, 0, 1 plus n x minus 1, let's go ahead and solve for x. And I'll slow play it a little bit so that you don't get confused. N x minus 1. Divide by n. So negative 1 over n is x minus 1. So x is 1 minus 1 over n. And I need to find the area of t. So now I have that x value. Now I'm here. Okay. Let me zoom back into the picture. Had to process. This right here is 1 minus 1 over n for the x value. This right here is 1. So that means the distance there is base of t is 1 minus 1 over n, which equals 1 over n. So area of t is 1 over n times 1 divided by 2, which is 1 over 2n. And I have done what I have been asked to do. So I didn't need to use the 1 over n plus 1 that was the first thing that popped to my mind. But I'm guessing that those two are going to come into play. And let's see. Let L be the line tangent to the graph, still that same stem. S is the region bounded by the graph of x to the n, L, and the x-axis. Express the area of S in terms of n. Determine the value of n that maximizes the area of S. Whew, there's a lot going on there. We know from previous work the integral 0 to 1 is 1 over n plus 1. We know from previous work the area of t is 1 over 2n. So S, area of S, plus the area of t is going to be the integral 0 to 1 x to the n dx. And I don't know S, but I know t, and I know x to the n. So that means S is 1 over n plus 1 minus 1 over 2n. And now I want to maximize S. So to find max, to maximize S, I need S prime to be 0 or undefined. So let's find S prime. Well, I'm going to go cheat. I'm going to go back up here. N plus 1 to the negative 1. Nope, not plus. Minus 2n to the negative 1. So then S prime, or dsdn if you would prefer, maybe that's more descriptive, would be negative n plus 1 to the negative, 2, minus negative 2n to the negative 2 times 2. That extra 2 there is because of chain rule. I didn't need chain rule in the first expression because the derivative of n plus 1 is just 1. But in the second expression, the derivative of 2n is 2. So let's look at what we have. We have dsdn is negative 1 over n plus 1 squared plus 2 over 2n squared. And I need to figure out if that is ever 0. So let's get a common denominator. So I have negative 2n squared plus 2n plus 1 squared, n plus 1 squared, 2n squared. And if I look at the top of that, that's going to be negative 4n squared plus, if I multiply this out, that'll be n squared plus 2, I'll write it down, n squared plus 2n plus, that's an x, plus 1. Double that, that's going to be 2n squared plus 4n plus 2 all over this n plus 1 squared 2n squared. Now, what did they tell me about n? N is greater than 1. So since n is greater than 1, I can just completely ignore the denominator. So I can say ds dn is never undefined because n is greater than 1, because the bottom is 0 at -1 and at 0. So I need negative 2n squared plus 4n plus 2 to equal 0. Well, doesn't that mean I'm going to go ahead and divide by negative 2? N squared minus 2n minus 1 equals 0. So I'm going to go ahead, I like completing the square, so I'm going to go ahead and complete the square. So I have n squared minus 2n equals 1, which means I need a plus 1 here and a plus 1 here. So n minus 1 squared is 2. And let's go ahead and solve. So n is the square root of 2 with a plus or minus, and then add the 1. I don't need 1 minus the square root of 2, so n is going to be 1 plus the square root of 2. Now, to make myself feel better, ds dn, I want to think about this, 1 plus the square root of 2. If I plug in, really I have 1 minus the square root of 2. And this is a parabola facing down, so I'm going to go positive to negative. So I'm going to have a max. So my justification is a max on S because ds dn changes positive to negative. And that's all I have to do. All right, so that was quite a question. And the first question wasn't too bad. It was just the fundamental theorem of calculus, the evaluation portion. And then the second part, I had to find the triangular region. So I had to figure out the equation of line L, basically, and then use that equation to figure out the x-intercept and use that to find the area. I don't know if that was the best route, but that's what I did. And then for S, I just combined my whole area with my t area, and I could get the S area, and then I had to solve a quadratic. Let's see how we did. Okay, part A, no big deal, we did that. Part B, 1 over b is the slope of line L, which is n. Okay, that's not, to me, that's not an obvious claim. 1 over b is the slope of line L. I can understand that that would be true, but that's why I did the argument I did. And then for the last part, I subtracted those, and then, they did an interesting move on solving the quadratic right here, where they just took the square root of both sides, which is dangerous because technically you need a plus or minus. But in this case, we didn't have to worry about it. But that is all we had to do. Now, this is a 2004 question, so we would need justification over here for why that is a max. That's why I said the positive to negative step. So make sure you do that.